Okay, first we have a picture of the situation. There's the ramp just before the trombone fell. And here's the trombone case. Looks a little bit like a chicken stick, a chicken leg. There's my dotted line around the object of interest, and of course the Earth is here too. Now, as it fell, there was a acceleration in this direction, so I'll have my motion diagram will represent that. And we have acceleration in this direction. Okay, so my force diagram, you can be sure will have net force in the same direction. So let's see. We know the Earth is exerting a downward force. So here's my force diagram, which represents the trombone case. There's a downward force exerted on it by the Earth. And there's a normal force exerted perpendicularly to the surface of the cardboard. Here's the surface of the cardboard right here, 90 degrees to that. It's the normal force. So at that angle is the normal force. And we'll call that the force that the cardboard exerts on the trombone case. Oh, I forgot this one. The force that the Earth exerts on the trombone case. And what's the other force I'm missing? We have a perpendicular force exerted by the cardboard on the trombone case. There's also a parallel force. So that would be right here. Parallel to the surface, it's going to oppose the direction that the object is trying to move. The trombone case is trying to move in this direction. So we have a force exerted in the direction of up the ramp, and that force exerted by the surface of the cardboard on the trombone case. Now I'm going to rotate this because I'm deciding to use this as the positive y direction. I'm trying to use this as the positive x direction. So according to that, the normal force is in the positive y direction, and the horizontal force is in the positive x direction. Now let's break apart the components of the vector representing the force the Earth exerts on the trombone case. These are the horizontal and vertical components of the force of the Earth exerts on the trombone case. And we see, as we would expect, because the trombone case isn't accelerating away from or into the cardboard, the vertical forces balance out. However, the horizontal forces do not. These are the things that you're going to be looking for in all of your motion diagrams, in all of your force diagrams as well. You want to make sure that if there's an acceleration, then there is only an unbalanced force in that direction. This is why it's helpful to turn the reference frame. It would have been really hard to have a force diagram with net force in that direction if we had x and y like this. We'll get there later. Okay, now I have my picture of motion diagram and force diagram. Let me set up my Newton's second law equations. I'll do a vertical one and a horizontal one. Vertically, we have, I'll use a different color. Vertically, we have a vertical acceleration equals 1 over the mass of the trombone case times the force that the cardboard exerts on the trombone case, plus the vertical component of the force that the earth exerts on the trombone case. Just the vertical component. Then we have to set up the other Newton's second law equation. We have acceleration equals horizontal acceleration equals 1 over the mass of the trombone case times the force that the surface exerts on the trombone case. That's the parallel frictional force plus the force that the horizontal component of the force the earth exerts on the trombone case. Force the earth exerts on the trombone case, horizontal component. Bam. Alright. Now we need to find a relationship between all of these so we can, because we're looking for the mu value, but I don't see mu value in here anywhere. Okay, that's what we need to draw on our notes from before, and where we remember that the force that the parallel force exerted on an object is equal to the perpendicular force times mu. In other words, the force that the surface exerts on the trombone case is equal to the force that the cardboard exerts on the trombone case times mu. Frictional force is normal force times mu value. We're looking for this.